our adding and subtracting fractions. And for today, as I said, we're going to look at some slightly harder versions. So the only thing that makes it harder is that we've got denominators with variables, and they will be different denominators, so you'll have to work on making them the same. So first we'll just start out with a monomial denominator, 3 over 2x minus 1 over 8x squared. Now, over here on the right, for this one, since it's the first one, I'm going to give you some steps. Step 1, factor the denominators. Oops, running off. Let me scoot it over. There we go. Factor the denominators if possible. In this one, we can't factor these. They're just monomials. But on the next one, we'll need to factor. So if possible, factor the denominators. Step 2 would be to find the LCD. So that's where we're going to start on this one. Find the least common denominator. Step 3, rewrite each fraction using the LCD. So this is where we started back on 6-4. We were doing this, finding the least common denominator and rewriting the fractions with their least common denominators. And then finally, add or subtract and simplify. So we'll go through these steps for this problem, and for the next one I'll kind of refer you to the steps. The most important part, of course, the new part, the part that's different than regular fractions, is the step 1, 2, and 3 are more complicated, of course, because now you're just so smart. Okay. So for this one, again, like I said, we can't factor the denominators. So our first step for this one is to find the least common denominator that we could use. So again, let's look at the numbers. Between 2 and 8, I'll pause for a second. I see some of you are still writing. Izzy, smaller, you can go even smaller. 8, right. Good. So don't forget, sometimes the bigger number could be the least common denominator for those numbers. Between x and x squared. Remember, each of these fractions is going to be rewritten. In fact, I'll just show you. You don't have to do this part yet. I'm going to need to rewrite them into their equivalent fraction with that LCD. So they both need to go into that amount. It can't be smaller. Right? Like I couldn't use 2 for the numbers because 8 doesn't go into 2. It has to be at least as big. X or x squared. What's my LCD? X squared, right? We have to take the bigger. Think just like with the numbers. We can't use 2 because 8 doesn't go into 2. So by the same method, we can't use plain x because then this one, x squared, I can't turn it into a simple x because we're trying to multiply, not divide. So my LCD for this one, 8x squared. Again, when we did this LCD, this was back in 6-4 on Monday. So look at your notes for that if you get stuck on the step of finding the least common denominator. So that's step 2. Step 3, here's what I've started down here is step 3. We need to rewrite each fraction using the LCD that we found. So I have to make equivalent fractions, turning them into a form that has the same denominator. Let me give you a little hint on a test. On the test you'll be taking, I think I said it was Tuesday. I won't be here. I was going to say, one thing that you could do, but I won't be here for you to ask, unfortunately, is if you're not sure if you have the right LCD. But I don't know who the sub is, and they may not know algebra, so don't ask. Get good at it before Tuesday. That's my advice. Okay, Izzy. No. Here's the problem. Let me pause for just a second. I don't want to delay the test until I'm back because this is very specific just to this 8th grade math class. I need to get through this entire book as much as possible. And we are already at the point, like I compare each year, where was I at last year at this point, where am I now? And at last year, I kind of ran out of time at the end of the year for some of the lessons, and I'm exactly at the same schedule as last year. And the reason I need to try to get through this entire book is some of you are going to take a math placement test, probably around April, for whatever high school you end up going to, where how you do on that test determines your placement in math for freshman year of high school. If I can get through everything in this book as much as possible, you have a much better chance of passing that test out of algebra and skipping to the next level of high school math. Whatever I don't get to is stuff that you're not going to know when we get to that test. So in other classes, when I can slow down, this one is different. I can't slow down. We got to keep moving. Keep on trucking. All right. Hopefully by now everybody's caught up with their notes. We've started. Now the step, remember, is to figure out how do I get from this denominator to the next one. To get from 2 to 8, I did times 4, and from x to x squared, I must have multiplied by x. So I'm going to multiply my numerator also by that same factor, 4x. 3 times 4x, 12x. Oh, look at my LCD. How did I get from 8x squared to 8x squared? Well, I didn't do anything. Or you could say you multiplied by 1, but either way, times 1, it doesn't make a difference. So it turns out that our LCD was actually the same as this first denominator. That will happen on maybe the first problem or two that I gave you. Now, we do need to remember that it's subtraction. So I'm going to go ahead now and rewrite these. 12x over 8x squared was my first one, minus 1 over 8x squared. My answer will have 8x squared as a denominator, of course. And I combine my numerators. 12x minus 1. In this case, we don't need to add the opposite because it's just one term. You guys can remember minus 1. Can I factor anything in that numerator? No, I could try to factor out a 1, but that won't help. So in this particular example, we're done. There's nothing more we can do. Okay, second and final example. This is as hard as it will get this year. So if you can follow this, you'll be good. Deep breath, everybody. All right. A minus 3 over a squared minus 2a minus, I'm doing some minus examples, subtraction examples, because they do add that extra level of difficulty. And so I just want to show you as hard as it's going to get. Nothing should be harder than this. Second fraction, minus a minus 4 over a squared minus 4. Now we need to use our step 1. Step 1 says factor the denominators if possible. My first denominator, I can factor out an a, which is going to leave a minus 2. Once I've factored it, I'm going to go ahead and cross out that denominator. For you guys, if you wanted to erase it in pencil, you could. I'm going to cross it out. We're not going to use that original denominator again. We are going to keep it in its factored form. So I'm just crossing it out so I know which one to look at. Second denominator, this is the difference of two perfect squares. A, and 2, and 1 gets a plus, and 1 gets a minus, and I'm not going to use those binomials again. Once it's factored, we don't use those original denominators. You might get a trinomial denominator, which is just reverse FOIL, and you'll get 2 binomials. Okay, step 1, done. Step 2, find the LCD. Everything, we need every factor in our LCD. So I've got this little a, I need to use it. I've got an a minus 2. I've only got 1 in each, so I only need 1. The only time you need to square it or have more than 1 is if one of these has the same thing twice. Think back to the x squared up here. When I had x squared and, where is it? Oh, it's all the way up. Oh, there it was. When I had x and x squared, I have to take the square because they're squared in one of them. Neither of these is squared. So I just take one a minus 2, and then there's also an a plus 2. You've got to take every factor and put it into your LCD. Okay, so there's our LCD. Step 3, let me scoot this up. I'm gonna rewrite it using the LCD. Now for my original denominator, I'm still gonna use the factored form. I'm never gonna go back to that original binomial. And I know this is a lot of writing. The good news is because these problems are so long, there won't be very many. So I take my first fraction, a minus 3 over a times a minus 2, and I set it up where I've got my LCD, a times a minus 2 times a plus 2. Part of the hardest part of this is actually just writing it all down and not making mistakes when you write. To rewrite the fraction for step 3, I need to figure out how did I get from this denominator to this one. What's the difference from here to here? What do I need to multiply the left side by to get it to look like the right side? Kate?
A plus 2.
Yep, the only thing that's missing is times a plus 2. Now, again, this is as hard as it's going to get. Let me just point out that on this one, a minus 3 is a binomial. It doesn't have the parentheses, but it is a binomial. And I'm going to multiply it by another binomial. What do I get when I multiply two binomials? Daniel? Good, we're going to FOIL it, which will give us a trinomial. I'm going to do that right now before we move on. FOIL, a times a squared. Outer. And in this case, I'm not even going to, I'm going to just do the outer and the inner separate, so we'll actually have 4 terms. But a times 2, 2a. Inner, negative 3 times a, negative 3a. And last, negative 3 times 2, negative 6. Again, I'm showing you this one because this puts everything in there. So you'll see everything. I know, deep breath. We're still on step 3. Step 3, we rewrote the first fraction. Now we need to rewrite the second fraction. A minus 4, it was over a plus 2 times a minus 2. I'm going to turn it in to its LCD. Okay, so I go and get my second fraction, still with the factored denominator. I never go back to that original binomial. This one will be a little simpler, don't worry. No foiling here. Because after we set it up like this to convert it from the original fraction to its one with its LCD, we just look and we say, how do I get from this first denominator to the second one? What do I need to multiply this by to make it look like this? Jim? Yep, this plain little a is the only thing that's missing. So I'm going to multiply by a. Now again, I have to multiply all of a minus 4 times a, but it's not foiling, I'm just distributing. A times a squared, negative 4 times a, negative 4a. Again, I know these take a while. You won't have very many of them. Okay, we finished step 3. Now for step 4, here's what I'm going to do. I'm going to go back to this one where I've already written the first one. I don't want to write that whole thing again. So I'm just going to bring this second one up next to it. And here's what's important. I said at the beginning, this is a subtraction problem. Minus. Now, I'm going to rewrite this, but we know it's the same. Right? Minus, and then I had, here's my second fraction, a squared minus 4a that I got right here. And I just write it next to it so I can subtract. If you can do a little shortcut so we don't have to rewrite that first one, that's fine. I'm subtracting the whole second fraction, which means I'm subtracting this whole numerator, which means I want to add the opposite. I change this to a plus, I change a squared to a minus, and 4a to be positive. So I've got this right here. Now, I'm going to just pull this to the left a little bit so that I can put my answer on the next piece of, maybe try to show it on the same. I don't know if I can fit this all on one screen, it's so long. Equals a times a minus 2 times a plus 2. My denominator doesn't change. rather than just rewriting this all together, let's look at it and see if we can combine our like terms right here. A squared minus a squared. Hey, go away. A squared minus a squared, gone. Now I've got a couple plain a's. 2a minus 3a makes negative 1a, right? 2 minus 3, negative 1a plus 4. Negative 1 plus 4 makes positive 3a. So now again, if we want to cross them out, although they didn't cancel, I've already used all the a's. If you want to do that just to keep track of where we are. Finally, minus 6. If only we were done. What? I told you. Okay, guys, we're almost done. That's step 4. We're done with step 4. Step 5. Simplify. We're almost done. Think to yesterday. I said if you can factor, you need to do it. Can I factor this numerator? Yes, I can take out a 3, which leaves a minus 2. And now hopefully that I've done that, you can see why I had to do it for this problem, because I'm going to be able to simplify one piece of this. When I factor out the 3 and it leaves a minus 2, that's being multiplied. This is being multiplied in my denominator. I can cancel whole binomials when they're being multiplied. Those cancel out. Final answer, this time we're done. A times a plus 2 is my denominator, and 3 is my numerator. Well, how about I'll clap for you when you get one right. You don't have to clap for me.